This conference will now be recorded.
I don't know why this happens nowadays. Oh, just a minute. Okay, now it is stable. So, Deepa, today I will be discussing about digital and analog circuits and logic gates. So this is very simple, but very easy to learn. But there will be definitely one question from this part in any competitive exam. So let us learn this topic today. First of all, we'll learn what is analog circuit and what is digital circuit. So analog, the word analog is actually meaning the continuous process. Okay, continuous signals is actually the analog. We'll define what is analog signal first, then we'll define what is analog circuit. So what is analog signal? A signal in which, signal means I can say whether current or voltage both can be thought as signal. So a signal in which current or voltage vary continuously with time is called analog signal. So I can show you a analog signal, like an analog signal here. You can see this is, suppose anything, maybe current or voltage, whatever it is. Look, this signal is actually continuously varying. It has continuously meaning, what is the meaning of continuous? Continuous meaning it has values at each and every time. You look, this is one value at this time, and this time. So if you see, at each and every time there is certain value of this signal, and it varies continuously. It varies continuously. So this type of signal is called digital, analog signal. Like if you take a very simple and symmetric signal, that is the sinusoidal signal, that is one kind of analog signal. And whatever we have learned, diode, transistor, amplifier, oscillator, these are the devices which are based on the operation with analog signals. Okay, see, the circuits which processes the analog signals are called analog circuits. The circuits which produces analog signals are called analog circuits. Okay, in analog circuit you can have values from 0 to any value, any defined value. Suppose if I say a current source, analog current source or voltage source, let me take current source of some 15 ampere, this is the maximum value and 0 is the minimum value. So the device can produce any value in between this limit 0 to 15. Okay, and see, in analog circuit, if you remember, in the galvanometer, like when we have seen in the galvanometer, like when we converted galvanometer into an ammeter or a voltmeter, we see there will be a pointer, right? Pointer or indicator. This is 0 value, and it can vary continuously. There will be gradual increment or decrement of the values. Gradual increment or decrement. Okay, each and every angle of deflection you get certain value, right? So this is actually analog voltmeter or ammeter. But there are digital also. We'll discuss those. Digital, you see some values like 8 volt, 12 volt, 10 volt. You see some digits like electronics watch, etc. Those are actually digital. Those are processor of digital signals. Actually, whatever digits we see, suppose 12. Actually, this digit, like this number, is composed of some 0 and 1, composed of some zeros and 1. So that is digital circuit. Digital signal means it can take only two values, either 0 or 1. Okay, that's why it is actually digital. Digital has two-step process, either low level or high level. Either switch is on or off, kind of that. So in our day-to-day life, we come across various various words like true or false, various statements like true or false, motive is good or bad, right or wrong. So these are actually two valued systems. So digital circuit is actually, or digital signal is two-valued system. We'll see that. It take up either low state or high state. There is no in between states. Okay. So digital circuit is this one, a signal in which current or voltage can take only two values is called digital signal. The electronic circuit which processes digital signals are called digital circuits. Like digital multimeter, digital voltmeter, electronic watches, pocket calculator, etc. These are digital devices. So in this, you might be thinking, sir, we see various numbers in calculator. How do you see that? You are saying digital circuits can take, or digital signal can take only 1 or 0, either low or high value. There is no in between, like no values in between. Then how is it possible that we see in the calculator various numbers? Like whatever number it is, we see 1, 2, 10, 12, 1000, lakhs, various numbers we see in calculator. Actually, these numbers are encoded with digital codes. Okay, digital codes. Any number you take, it is shown in it can be shown by Boolean algebra, but Boolean algebra is not uh, included in your syllabus. You will learn it in electronics part in the higher classes if you go with the physics subject or maybe electronic circuit, like electronics subject. You learn this Boolean algebra where, like, suppose 59, this number can be written in terms of 0 and composed, like it is not true. I'm just simply writing. So maybe 1 0, then 0 1, then 1 1 0, like that. It is coded with this digit. Okay, 0 or 1. You are seeing in the calculator some number 50, 60, 70, or maybe any number, but those numbers are actually coded with this digital values like 0 or 1. Okay, and see, whatever computer nowadays we have, like computer doesn't know analog signals, they know only 1 or 0. You give input, it like input in terms of, like it reads the input in terms of digital digits like 0 or 1 and give you the analog output. Okay, it reads the signal in terms of digits or digital signal, but it gives you as analog output. Okay, it gives analog output. This is the thing. There are converters, digital to analog converters or analog to digital converters also in electronics. So anyway, digital multimeter, digital voltmeter, electronics watches, there you see digits, right? That's why it is digital devices. And see, this is digital signal. As I said, it can take only two values, 0 or some high value. Look, this is low. 0 means low state. So if I just say this is T1, this is up to T2, this is T3, like that. If I just say the time, so in between, see, when the time is 0, it has how much values? It has actually high value. Okay, 5 volt. As soon as time is becoming T1, the signal becomes 0, and it continues up to T1 to T2. So in between it will be 0. Again, when the time just crosses the T2, it has a value 5 again. Okay, and in between T2 and T3, the signal is high. Now if I write this is T4, in between, see, as the time increases just little bit above the T3 time, then it becomes 0, and it continues up to T4. So this is how digital signal can take only two values, either 1 or 0, or low state or high state. See, this 0 can be defined as 0, and this 5 volt can be defined as 1. That means I can even define this as low state and this as high state. Okay, or high level and low level. So low level actually is represented by 0. Okay, and high level is represented by 1. So in digital circuits, either your signal can be high at particular time or low. It cannot have both also. It can have either low or either high or either low. Okay, anyway, so this is the thing. So digital circuit takes 0 or 1, or high state or low state. Now we'll see what is Boolean operator. Okay, so Boolean was an English mathematician. His full name is George Boole. George Boole. English mathematician George Boole. He actually introduces the two-valued logic in mathematics. Two-valued logics in mathematics. And then he had given a new mathematics called Boolean, or new algebra called Boolean algebra. As I was saying you, in that Boolean algebra, what is there? See, in the Boolean algebra, how 12 can be written in terms of 0, 1, etc. Okay. How I can just give you an example that Boolean algebra. Boolean algebra can tell you how many zeros or how many 1 will be there for 12. Okay. So Boolean algebra is not included in your syllabus. We are not going too much in that. Boolean operators. We need to know what are Boolean operators. Actually, just as we have various operations in normal mathematics, what are those? Like addition, then subtraction, then division, multiplication, etc. Similarly, in Boolean algebra also there are few operators. Those are AND operator, OR operator, NOT operator. These are the basic operators, okay? These are the basic operators which Boolean algebra uses, okay? These are Boolean operators. So in the Boolean algebra, what you get, any number, how to express in terms of zeros or one, okay? That is actually briefly Boolean algebra. And in Boolean algebra, there are operators like AND, OR, and NOT. What are these operators and what are like related to these three operations? There are some basic building blocks or basic circuits made based on the operation of AND or NOT. Those are called logic gates, okay? So what is OR? I'll just give you one simple example. What is OR operator or AND operator? Let me give you AND operator. So suppose you have two bulbs, okay, two bulbs or two switches. I say two switches. This is a battery, this is positive, then you have this is negative, okay? So this is the battery with which there are two switches, okay? There are two switches, suppose S1 and S2. This is S1 and this is S2. There are two switches, and along with that there is a bulb connected over here, okay? There is a bulb connected over here in series. This is the bulb, sorry, bulb here, okay? So look, and operation is saying that if both the switches are on, then only the bulb will glow. Look here, since this bulb is series with these switches, if the both switches are on, then only your bulb will glow. That means you can have two or more inputs, if both are at high state, then only you will get an output of high state, otherwise it will be output at low state, okay? This is a simple example of AND operation. I can show you OR operation also. So in that case, the switches are in parallel. There are two switches parallel to each other, and obviously with these parallel switches there is a bulb connected in series. This is battery, connected like this. Look now, this is S1 and S2. So when the bulb will glow, can you guess? See, if suppose this is open, and this is closed. Then the whole current will flow through this way, but current is not going to get interrupted. That's why the bulb will glow. Similarly, if I keep the upper one S1 open, then the S2 close. Okay, sorry. Closed. Then also the whole current will pass through the bulb. So in both cases, you see that bulb will glow. So this is called OR operation. We'll see in the OR operation, it is somewhat meaning the addition. Okay. And AND operation, somewhat it is multiplication. So those things will see. Like this is OR operator. NOT operator is, look, this will give you, if it has actually, NOT operator has only one input and one output. Okay, so let me draw that. Suppose this is a battery. The bulb is connected here somewhere. Now the switch is connected here. This is a single single input. Switch means inputs. Look, now this is positive, this is negative. If the switch is closed, then this NOT gate, what it gives, see, this has certain resistance, right? At least greater than this path. Always current will always find, or it will try to pass through the lowest possible resistive path, right? It will pass through a lowest possible resistive path. So the bulb has greater resistance than this path. Suppose this is one path for the current to flow, another path is this one, right? To current to flow. So when the switch is on, the whole current will pass through this way, through the switch, because current always prefers to flow through the path which has the lowest possible resistance. Okay, but now if the switch is open, then anyway current is flowing through this, right? That means, when you have input 1, you get output 0. When your input is 0, that means it is open, then you get the output to be high, that means the bulb is glowing. So this is the situation with the 3 basic operations. I hope you have understood. If not, you can ask me, Deepa. And, OR, and NOT, these 3 basic operations are there in Boolean algebra. Okay, and based on these basic operations, there are basic circuits, logic circuits are built. Now we'll learn what is logic circuit or logic gate. So logic gates are basic building blocks of digital circuit, in which diode or transistors, or maybe together, they are used for performing switching actions or switching functions. Okay, and if you define a gate is a digital circuit which is designed for performing a particular logic operation. A digital circuit that is designed for what? For performing a particular logic operation. This is called a gate, and it works according to some logical relationship between input and output. See, logic operation means there is a logical relationship between inputs and outputs. Okay, based on this logical relationship, it will produce output. Okay, a logic gate may have one or more input terminals. We have seen, see, in case of OR gate, you can have any number of switch here, right? That's why OR gate can have OR gate. See, these switches are actually equivalent to inputs, and see, the bulb is glowing, only one bulb is there, so actually the result is 1. That's why whatever may be the input switches, there will be only one output. That's why it is said that OR gate and AND gate can have many number of inputs, any number of inputs. Okay, at least 2. You need at least 2 or more. At least 2 you need, not any number, I am sorry. At least 2 or more than 2, any number you can take. Okay, but output will be only 1. See, in case of NOT gate, it has only one switch, so it has only one input, and only one bulb is glowing or it is not glowing. That means the operation output is only 1. Input is 1 as well as the output also 1. Okay, now let us see how many logic gates are there. Okay, what are those logic gates, and we'll try to learn those logic gates properly. So there are actually 3 basic logic gates. Okay, how many? There are 3 basic logic gates. Basic logic gates based on the basic operations. We have learned already what are the basic operations. So based on basic Boolean operations. Okay, that means how many gates are there? 3 gates are there, basic gates. Let me start with not gate, then AND gate, and you have OR gate. So these are 3 logic gates. Okay, 3 basic logic gates. Now we have already learned about their operations. Now we will see for each gate how to symbolically represent each of the gates, and how do we express their input and output relationship. Input output relationship is expressed in terms of a table called truth table. What is that called? Truth table, or Boolean expression. This is from directly from Boolean algebra. Okay, Boolean expressions. These are two ways to express or represent the input output relationship between, like, for different gates. Okay, now we'll go to first NOT gate. Let us take NOT gate. So NOT gate has a symbolic representation, like, see, you might have drawn this for diode, right? If you just give a simple vertical bar, it will be a diode, but we are not going to draw it here. Okay, so instead what we'll give a bubble over here, and then like this. So this is the symbolic representation of NOT gate. Okay, this is symbolic representation of NOT gate, and this side, left hand side, it is actually represented as input. This is input, and this represents output. Okay, this represents output. Okay, now look, so how do you write truth table? Truth table generally is written like this. Suppose you have, sorry, you have input, okay, or S, and then output, only one output. So input, you have only one input. That's why I'm not taking multiple input, only one input I'll take, and corresponding output I'll write. See, we had already seen in the NOT operation, when it is at high level, that means if this is 1, then your high level in the sense, see, if the switch is, sorry, logic operations, yeah, if the switch is on, then bulb will not glow, that means your output will be 0, right? So if you write input 1 or at high state, then your output will be at low state. Okay, or if the input is at low state, then your output will be at high state. So this is the truth table for NOT gate. Generally, Boolean expression is written like, see, if this is A, then output Y will be A bar. So see, 1 bar means 0, or bar of 0 means 1. So this is what you can remember. 1 bar means 0, or 0 bar mean 1. Okay, or if you say your input is at high state, then if I just give a bar, A bar means your input is at low state. Okay, or B bar means input or output, whatever it is at low state. Okay, or if I simply write A or B, these are at high state. Okay, so let us write. Okay, we have already written. So if A is the input, then output can be written as Y is equal to A bar. A bar means whatever may be the state of A. If it is at high state, then the output will be at low state. If the input is at low state, then output will be at high state. Okay, so this is the case. Now we'll go to the AND gate. AND gate. So you look here, in this case, you'll get output high state or output as on only when your input is off. Okay, or if you have, in other words, if you have input low state, you will get output as high state. In the AND gate, what is the symbolic representation? The symbolic representation, and see, this will be simply having a shape of D. Okay, and gate, so this will have a shape of D, and you can have input any number of inputs. Okay, any number of inputs here. Okay, let me just remove this one. So you can have any number of inputs like A1 to A2, it can go up to AN. Any number of inputs you can have, but how many output you have? Only one output you will have. Let me just clean this and write. For the time being, I'll just take two inputs to show you how truth table or Boolean expression is written or can be written in case of AND gate. So these are two inputs, suppose A and B, and here this is output of Y. For this case, what will be the Boolean expression? I'll write the Boolean expression. So your Boolean expression will be A dot V. This is somewhat multiplication, kind of multiplication, but this, in case of digital circuit, this represents AND operation. Dot means AND operation. Okay, AND operation. We may silently say that this is A dot B, but in terms of the language of digital circuit, it is AND operation. Okay, so this is the Boolean expression for two valued or two input AND gate. Okay, now how to write the truth table and what is the significance of this AND operation? Let us draw the truth table. Let me write these inputs, and here Y A dot B. Okay, and so this is inputs, here output, only one output. It has many inputs, it may have many input. Okay, many inputs we can have, but only one output you will get in case of any logic circuit. Output will be only one. Suppose this A and B. So A can be either at high state, a high state means 1, meaning is 1, and low state meaning 0. So either A can be 0. Let us say both are 0, both are at low state. That means both the switches are open. If both the switches are open, so if both the switches are open, then what will happen? The bulb will not glow. If you remember, see, they are in series like this. Okay, if both the switches are open, then this bulb will not glow, isn't it? S1 and S2, or A and B. If both are open, that means both are 0, then bulb will not glow. That means output will be 0. If this is 1 and this is 0, then also, see, if since they are in series, if one is open, another one is closed, then also you will not get any output. Now, if this is 0, this is 1, the similar thing, one is closed, another one is open. Now, if both are closed, then see, they are in series, so current will flow through the bulb and you will get input output 1. So you can see in the AND gate, you'll get output at high level only when all the inputs are at high level. Okay, all the inputs have to be at high state, only then you will get any output. Okay, any output, sorry, not any output, you will get high state output at high state. That means the bulb will glow. If both are closed, then only the bulb will glow, otherwise not. If one is open, another one is closed, then at this condition there will be no output at all. Okay, or there will be no glow of in the bulb. So see, in terms of Boolean expression, this is y is equal to a and b. Okay, this is the output. Now we'll go to the last one, that is, let me clean this portion. So the last one is OR gate. OR gate. So I hope you remember the OR operation. In this case, what happened? We had taken two switches parallel to each other, and the bulb was connected like this. Okay, with the battery like this. So in this case, either of the switch, suppose this is B and this is A. If both the switches are on, then also this bulb will glow, or either of these switches, A or B, either of these switches is at high state or closed, then the bulb will glow. That means, let me write the circuit symbol or symbolic representation. Since it is O, like OR gate, look how we write O. O we write like this, isn't it? So the OR gate have this curve from O. Like half of the O I'll write, okay? Half of the O I'll write, and then I'll write like this. I'll draw like this. Okay, so this will give you the output of the OR gate, and these are the inputs. So you can have any number of inputs for OR gates, but least number is 2. At least you should have 2 or more than 2. So this is OR gate. And what is the Boolean expression? Suppose this is A and this is B, then the Boolean expression for the output will be A plus B, but this is in terms of algebra, it is A plus B, but this operation is called OR operation. This is called OR operation. Plus sign is OR operation in case of digital circuit. Okay, now let me write down the truth table for this. Truth table for this. So truth table is, let me for the time being take 2 inputs. So these are the inputs. This is output. Output will be always only 1. So I can have either A. So let me write, this is A, this is B, and this is Y is equal to A or B. Okay, this is how we have to read. So suppose the A is at high state, that means let me write first 0 0, both are low state. If both are low state, then the output also will be low. All right, if I have switch A at high state or it is closed and this is open, then also we'll get output 1 or at high state or at high level. Similarly, if this is 0, this is 1, then also we'll get output as the high level. And if both are 1 and 1, then also we'll get output. Okay, so here OR means either of the inputs, if either of the inputs is at high level, then your output will be at high level. Okay, so or you can just for the sake of remembering this thing, or means you can think of additive according to our simple algebra, and means it is dot product. So this is how we can always think of. Okay, now we'll go to see few special gates. Okay, one or two special gates we will be discussing, then we'll stop the class. So another like one special gate is, suppose NAND gate. NAND gate. So what do you mean by NAND gate, and how to remember what is NAND gate? See, NAND, you have already and what is this N? You have to say not for N and plus and. That means you have combined not an AND gate. That is what is NAND gate. But obviously you have AND gate first, then you have the NOT operation. See, this is AND gate. Suppose A and B, these are two inputs. So we get here output Y as, suppose Y1, A dot B, right? We get A dot B. Now when we take NOT operation of this A dot B, the final output will be A dot B, or A and B over whole bar, because NOT operation will give you the whole bar only. So this bar as and you can convert it to OR also. So this can be written as A bar or B bar. Okay, this can be written like this, or like reverse is also true. If you have A, okay, so suppose A plus B whole bar, this can be written as A bar and B bar. So both are true. Okay, so this is according to Boolean algebra. So this is the NAND operation. NAND means first you have to do the AND operation, then you have to take the bar of your AND result, because after that you are going through a NOT operation. This is AND operation, and this is NOT operation. Combined circuit symbol will be just a bubble. If you add along with the AND operator, sorry, AND gate, then you get NAND. And with a bubble, this is actually representing NAND gate. In your exam, this will not be there like and then not like that. It will be given a compact circuit symbol, that is the and along with that there will be a bubble. You can see in your book also. Okay, now how to write the truth table for this? Look, I'll write A and B both inputs, and Y as output. I have got A bar plus B bar, right? This is what we have got from the Boolean expression. Now look, if I take various input, what we will get? So if we get 0 0, that means your output will be 0 bar or 0 bar. That means 1 or 1. See, according to Boolean algebra, when both the switches are at high level, then you get output high level. So 1 plus 1 is not 2. It is not 2. Okay, it is 1 only. Sorry, 1, and 1 plus 1 is 1. And 0 bar plus 0 bar, that means 1 plus 1, that is also 1. Okay, this is what it is told here. Okay, so I'm not writing this again. I'll just write the final result. So you have 0 bar 0 bar 0 bar 0 bar means 1 plus 1, that means you have 1. Okay, now you look, if you have 0 1, then you get this, for this you get 1, and for B you'll get 0. So finally you'll get 1 only, high state only, right? Now if I write this as 1, this is 0, then also you'll get high state. If I write 1 1, that means you get 1 bar plus like 1 bar. So both are 0 0, 0 plus 0, you'll get 0 output. Okay, so you get 1 1 when both the switches are on, you will not get in output, you will get 0 output. So in this case, you look in the NAND gate, when both are at high state, both the inputs are at high state, then output will be 0. Okay, okay, so output will be 0. Now we'll learn another special gate. Let me remove this. Another special gate, then we'll conclude the class. That is NOR gate. NOR means what? Similar to NAND, NOR gate. So this is OR, along with that NOT operation. So N for NOT and this for OR operation. So this is NOR. Okay, so what is the circuit symbol in this case? So OR gate I'll draw first. OR gate, along with that there will be a bubble over here. If you have a bubble, then it is representing that there is NOT operation just after, NOT operation with the output of OR gate. So in this case also you can have many number of, like more than 2 number of inputs. So let me take here as only 2 for the understanding purpose. So this is NOT operation. Here it is the ultimate output. So what you get, you get OR means A or B, and then you have to do the NOT operation like this. You have OR and then you have NOT like that. Okay, so if you have A and B, so OR will give you A or B, and see this NOT gate is saying that you will get the final output to be A plus B whole bar, sorry, A or B whole bar. So A bar dot B bar, like that. Now let us, okay, so the final output will be A bar dot B bar. Since you don't know the Boolean algebra, you can remember up to this also. You can remember up to this. So you'll get A or B whole bar. Ultimately, you will get A bar dot B bar. Now let me write down the truth table. A, B, then this is Y. See, Y means A bar dot B bar. So if you have 0 0, Then what? 0 means 1 dot 1. That means what? You get high input, right? High output. Now if one is A is, suppose A is at high level and this is at like low level, then you get 0 output. You can just cross check from here, because this 1 bar will give you 0, right? Now if you have this 0, this 1, then also you'll get 0, and if both are 1, then also you get 0. So you can see in the NOR gate, you'll get output only when both the input switches are off or at low level. Okay, then only you'll get output. So I hope you have understood whatever I have discussed. So I'll stop it here. Next day we'll take up various numerical problems on these gates. Okay, various gates will take, various circuits which are already asked in competitive exams. We'll take up those questions and try to solve. Okay, Deepa, thank you for your patience. So bye for today.